Okay, for starters, simplifying ratios. Simplifying ratios. I'm going to be a little bit more lenient than the book is. If you've already done these problems the way the book asked you to do them, you're going to be fine. If you haven't and you just want to do them this way, that's fine too. Ratios, they're all over the place. Okay, there's scales on a map. 1 inch is to 50 miles. The ratio of when you, that is used when you build model cars, little figurines, statues. We kind of talked a little bit about this already. Okay, ratios are very important. We got to maintain that same ratio all the time to make things look proportional, to make things look correct. All right. Simplifying ratio is also very important. Okay, it's just easier to use a simplified ratio. If a person is 6 feet tall in real life, but we want to build a statue to represent them or of them, that's 24 feet tall. Okay, so you got the real life here, you got the statue here. If they're 6 feet in real life, 24 feet on the statue, what is the ratio that we want to use to help us build the statue? 1 to 4. So 1 foot in real life is 4 foot on the statue. Okay? So for lack of better purpose, if their feet are actually 1 foot long in real life on the statue, make it 4 feet. Okay? Okay? Well, I mean, it would be proportional though, because you won't want to just kind of guess on how big to make the feet. If the statue is going to be 24 feet, okay? If the ratio is truly 1 to 4, we got to keep it 1 to 4. Otherwise, you'll have this big, tall guy with these feet about that big. All right? It'll look kind of silly. So not proportional. So maintain the same ratio all the time. When you're going from maybe inches to feet, the book had you do a couple different things. Like let's say we had 2 inches in real life would be, oh, I don't know, 6 feet on the statue. Okay, 2 inches to 6 feet. Okay. The book had you change the inches to feet or the feet to inches and do it that way. If you did that, great. Go for it. Okay? I'm actually fine if you keep it the same as long as you reduce it. Alright? Just because if you're going inches to feet, let's leave it as inches to feet. Okay? If you're doing this as far as a conversion of a figurine or a statue or a model car or something like that. Okay? So, there's one of 2 ways to simplify this one. Keep it inches over feet. What would that reduce to? Okay, but then make sure you label 1 inch to 3 feet. This is okay if you want to do it that way. Okay? Or the book did ask if you would go ahead and get them to have the same dimensions. So inches over inches or feet over feet. Okay? Well, in order to do that, you got to change one of them. Okay? 6 feet.
I always change the bigger one.
Okay, change the bigger one is fine. 6 feet is how many inches? How do you figure it out? Times 12, right? 6 times 12 is 72. So really this is 2 inches over 72 inches. And then what would that reduce to? Say it, go ahead. You're right, yep, 36. Okay, 1 inch to 36 inches. So, this would be an okay way of doing it. If you want to leave it, probably easier for you that way. But if you did it this way, great, good job. You changed them to the same unit, and that's fine. I'll be fine either way. Simplifying ratios. Everybody good on this? Just simplifying fractions. Any questions on it?
If you're not changing them, do you still simplify them by the same number, right? Like, say you had like 2 over 10, it was like 2 feet over 10 inches. You still, like, if
Keep it feet over inches.
Yeah, but I'm saying if you're gonna simplify it, they're both gonna get simplified by the same number, which would be 2.
Yeah.
Okay.
Yeah. Because you'll notice it'll still work out. 1 inch to 3 feet, 1 inch to 36 inches. 36 inches
Yeah.
is 3 feet.
Okay.
So yeah, they're the same. Yep, gotcha. All right. Okay. Next part. Writing ratios. Let's say we have a rectangle whose base to height ratio is 2 to 5. What does that mean then in terms of the rectangle?
Yeah, 5 feet tall.
What's that?
Is it 5 feet tall or big wide?
So they're saying here
Yeah.
and here?
Yeah.
You guys agree, disagree?
Well, it's the only way it would have to be.
Well, could it be this?
Yeah.
Yeah.
Could it be this?
I thought you were meaning the 5 could go on the bottom.
Oh.
I'm like, no.
So, go ahead.
So the base would just be 2/5 of what the height would be.
The base would be 2/5 of what the height is. Yep, no, I like that. That's good. A lot of people are going to be afraid of fractions. I'm going to put it easier for you, but what you just said is fine. Yeah. Okay. So, he said originally 2 to 5. Well, not necessarily. It could be 4 and 10. It could be 20 and 50. It could be 40 and 100. As long as it always reduces to 2 to 5, right? Okay. So wouldn't you agree this has to be some multiple of 2? This has to be some multiple of 5. So how about call them 2x and 5x? Because won't 2x and 5x always reduce 2 to 5? Won't the x's cancel out?
Yeah.
Okay? Pick a number for x. Cross, pick a number.
Yeah.
Not 0.
6.
The length of this is not going to be 0.
2.
2. What's 2 times 2?
4.
4. What's 5 times 2?
10.
10. 4 to 10. Does that reduce 2 to 5? 4 to 10. Does that reduce 2 to 5? Yeah. Haley, pick a different non-zero number.
7.
7. 2 times 7 is 14. 5 times 7 is 35. If this was 14 and this was 35, would it maintain the ratio 2 to 5?
Yes.
Yeah. So x could be anything except 0 because we're working with lengths. Or negatives because we're working with lengths. Okay? Any positive real number. Okay? So, sometimes when you write ratios, you'll use x's in them on the picture. Now, to add on to this problem, I might tell you that the perimeter is 56 centimeters. Find the value of the base and the height. Find the value of the base and the height. So how big is the base? How big is the height? Well, it's not 2 and 5, right? It's not 20 and 50. You don't want to guess and check over and over again. Ariane, what's perimeter mean? In general.
It's the area around it.
Don't use the word area, but
Distance around.
yeah, good. Distance around it. Yep. Okay, the distance around. Okay? Well, the distance around this is 56. So could we set up an equation?
Yeah.
What do you got, Antonio?
56 equals 5x plus 2x.
56 equals 5x plus 2x. So if I just add those two sides together, that's my perimeter?
Alright, now.
It'd be
Maybe.
2,
Yeah.
2 parentheses 5x.
Okay, or do it again, right?
Yeah.
Yes, what you said would work, but she said just take 5x plus 2x and then take that times 2 because you got to do it twice. Or, really, 5x plus 2x plus 5x plus 2x, right? Add them all up. Brett, what do you get? Add up all the x's.
14x.
Okay? Divide both sides by 14. X is 4. can you tell me what the base and the height are? If x is 4, what's the base? 8. 2 times 4 is 8, right? So that's 8. 5 times 4 is 20. So this is 8, that's 20. Now you know what the base and the height are. Does it still reduce 2 to 5 if you do base to height? Does 8 over 20 reduce 2 to 5? Yep, so we got it. Plus it should add up to 56. 8 plus 20 plus 8 plus 20 makes 56. You did it right. You got the new base and height given the corresponding ratio. Okay? Everybody good on this?
Yeah.
Okay, I'm going to change it to a triangle. The ratio of 3 angles in a triangle are 4 to 7 to 9. Does that mean the angles in the triangle are 4 degrees, 7 degrees, and 9 degrees?
No.
No, because what do we know about the 3 angles inside of a triangle?
Yeah.
You gotta add up to 180, right? Have to. 4 plus 7 plus 9, that does not add up to 180, alright? Not really very close. So just like the rectangle one, instead of calling them 4 and 7 and 9, which you can't do because they don't add up to 180, but they gotta maintain that ratio, what do you think I'm gonna call them? 4x, 7x, and 9x. Now could you write an equation, Devin?
Yes.
What would that equation be? You don't need to add them together, just write the whole thing out.
4x. 7x.
Did you say plus?
Plus 7x plus, what's the other one? 9x.
Has to.
Equal 180.
Nice. 4x plus 7x plus 9x has to equal 180 degrees. Add or like terms. Is that 20 of them? So 20x equals 180. So x equals 9. So how big is this angle then?
36.
36 degrees. How big is this one?
81.
81 degrees.
64.
63 degrees, right?
63.
9 times 7, 63. Alright. So, what do you think?
Yes.
You get them okay? Alright. Page 360, 3 through 22 is your assignment. A lot of you have already done 3 through 10, which is great, so you don't have very many problems to do. Keep in mind for chapter 6 so far, page 349 needs to be finished and checked, and now page 360 should be finished and checked. I don't see why you wouldn't be able to have all of those done before you leave today and checked. My geometry book's there and here. Check your answers, okay? Turn them in, we'll get you marked off. Kind of a little bit of catch up right now, okay? Go.